All right, greetings everyone. Welcome to the second part of the video for section 6.1. Continuing on with our study of some of the features of the trig functions that we've been looking at in chapter 5. All right, so in the last video, we did some exploration of what the graph of a sine function would look like. Now we're going to look at what the graph of a cosine function would look like. And just like with sine, we want to use our knowledge of the unit circle together with a table to draw the graph. So I'm going to do that kind of quickly here. So I'm going to set up two tables here. I'm going to input the values from my graph. So 0, pi over 2, pi, 3 pi over 2, 2 pi, negative pi over 2, negative pi, and I may have to go through and fill in the other ones. So if I do 0 for cosine, that would be 1, pi over 2 is 0, pi is negative 1, 3 pi over 2 is 0, 2 pi is 1. Going back the other way, negative pi over 2 is also 0, negative pi is negative 1. And I'll fill those in and then come back. So we have 0. To do some labeling here. So I'll call this 1, this negative 1. So 0.01, pi over 2, 0, pi negative 1, 3 pi over 2, 0, 2 pi and 1. I have negative pi over 2 and 0, negative pi and negative 1, and then actually not going to put them in the table, but if I plug in 3 pi over 2, I'd get 0, and 2 pi, I'd get 1. If I connect the dots now, my graph for cosine will look something like this, okay? And notice, first of all, this is a periodic function, again, because if we look at the left-hand side, so this piece here, and compare it to the right-hand side, so this piece here, we more or less see the same shape, and it would be the same shape if I was better at drawing. So we see that it's a periodic function. We see it's a little bit different than sine because in particular here in the center, we start at the value of 1 rather than starting down here at the origin. And yeah, that's what I want to say about that for right now. So let's go through and do some of the same analysis that we did with sine. So first of all, the next thing would be, is cosine an even, an odd function, or neither? Or recall, as we said in the last video, that if it's an even function, it means I should be able to take this piece over here on the right, reflect it across the vertical axis, and get the same exact piece, or same shape. Well, if I do that with this one, notice we do, right? Reflecting the orange piece over to the left would line up with the green one. So it tells us that cosine is in fact an even function. The domain here, well, we again see on the endpoints, we see arrows continuing on and continuing on the same pattern to the left and to the right without any breaks. So it looks like our domain would again be all real numbers, or negative infinity to positive infinity. For the range, just like with sine, we see that the values are going to continue to be at highest 1 and at lowest negative 1, with the lowest points here and highest points here. Okay, we see how they would repeat, and they'd bounce between negative 1 and 1, so we know our range will go between negative 1 and 1. And the graph actually passes through those points, so we can put brackets there. And then finally, for the period of the function, well, again, I've highlighted the green and the orange here in my picture as kind of those periodic pieces, or those repeating pieces of the function. And notice that the first piece there goes from negative 2 pi to 0, which is the distance of 2 pi. And the second piece goes from 0 to 2 pi, So that's also a distance of 2 pi, so it looks like our period here is also 2 pi. So it turns out that for cosine, the domain, range, and period are the same as sine. However, cosine is an even function, whereas sine was an odd function. All right. Oh, crap. And I meant to leave that picture there because I wanted to show something else. So let me try to draw that out again. Okay, so again, here's our cosine function. And I want you to notice that if I were to highlight, say, this piece of the graph, what does that look like? Yeah, it looks like a sine function, right? And it looks like I could do that again if I extended this piece here to the left. I could do this and see another sine function there. And I could do the same thing to the right, repeat this and get that looking like a sine function. So it turns out that the sine and cosine function are actually the same curve. They've just been shifted one way or the other. So even though it's important and useful for us to talk about the sine and the cosine as different curves and having a little bit different shapes, what we see is that they're actually the same shape. Okay, again, just shifted left or right. And so because of that, both the sine and the cosine waves or shapes are called sinusoidal graphs, okay, or sinusoidal waves. Again, that's because they're basically the same shape, just shifted one way or the other. All right, now, again, now that I said that part about them being shifted, it is important, as I mentioned, to be able to identify whether something is a sine wave or a cosine wave. And one of the big things that we can look for to identify what a graph is to choose a starting point and then look at where that starting point is in relation to something called the midline. Okay, and the midline is going to be a line that, just as it sounds, goes right through the middle of the function. So notice for sine, I've got that red midline there highlighted. And for where it starts here in our picture, notice it starts right on the midline. For cosine, we've got the midline in the exact same place, but notice in this case, the function starts above the midline. And so that's going to be a big difference between sine and cosine. In sine, the function starts on the midline. In cosine, it'll start above, or if it's been transformed, sometimes it'll start below. All right, last thing for this video, we're looking at something called negative angle identities. So these are going to be additional identities we'll want to put into our toolbox, our identity toolbox, to be able to use when we're solving identity type questions. And so we want to know what sine of negative theta is equal to and what cosine of negative theta is equal to. And to answer these questions, what we're going to use is the difference between even and odd functions. So recall we looked at sine and cosine, whether they were even or odd. And something you might remember about an even function, let's say it's called f of x. If f is an even function, then if we do f of negative x, meaning we make the thing that we're plugging in negative, that's actually equal to the same thing as f of x. Okay, so the negative sign doesn't change anything there. If the function is an odd function, okay, so if f is an odd function, then f of negative x is actually going to become negative of f of x. So the negative sign more or less moves to the outside. So we can use that here with our sines and cosines then to identify what these identities would be equal to. So for sine of negative theta, recall that sine was an odd function. So sine of negative theta then is going to be negative of sine of theta. That's what it will be equal to. And then cosine, recall, was an even function. So what that tells us is cosine of negative theta is actually the same as cosine of theta. All right. Great. Thank you guys for watching.